Okay, this is a special integral because in this problem we have x minus 2 to the power of 2. Let me kind of break it apart and show you what this looks like. So first of all, x minus 2 to the power of 2, that just means write down x minus 2 twice in a row. That's what it means to say something is squared. And unfortunately, with integrals, there's no product rule. So if you have a product like this, you have to actually multiply it out. There's no shortcut. There's no product rule for antiderivatives. So what you have to do is go ahead and FOIL. Basically, x times x, x times 2, then 2 times x. Those will be like terms. They will add up to negative 4 x, and then negative 2 times negative 2 is going to be positive 4 with the dx. And again, as usual, break each one of the integrals by itself into its own integral. And I'm going to factor out the constant terms right away. So I'm doing 2 steps in one on that line. I'm basically using the property 1 and properties 2 at the same time. So property 1 says break up the integrals. Property 2 says if you have a number, ignore the number from the integral and just leave the integral alone. So this next step is power rule for the first one, x cubed over 3. The next one is going to be a 4 on the outside, and then the antiderivative for x, which is x squared over 2. And then finally, the third one is going to be, again, a 4 on the outside with the antiderivative of nothing. That means there's a 1. So that becomes a regular old x. And then we have the plus c. So if you clean it up and make it look pretty, you get 1/3 x to the power of 3 minus 2x squared plus 4x plus c. And that's where the problem really ends usually. Okay, so this is where it normally finishes off. But there are instances, like the next problem, example 5, that we're going to be doing. There are instances where somehow you need to figure out the value of c. So there are times when you need to figure out what this number c is. Remember, c is a random real number, and most of the time we don't care what it is. But in example 5, they're going to give us some information that will help us determine what c is. And in those cases, when they give you information to figure out what c is, those types of problems are called initial condition problems, because they're giving you some information about when x is -1, the y is 2, to help you determine what c is. So let's take a look at that in the next video.